Hi, and welcome back to now really the first lecture of Introduction to Structured Programming. We are talking about data types, variables, and operators. So this is basically the start of programming. We start at zero, and we guide you a bit into the first ideas of programming and how programming works in general. There are a lot of topics, of course, and we will come to some topics in the next few weeks over and over again. But let's say this is really the foundation of programming and coding, so to speak. Okay, so as I said, we are in week 1, first lecture. Now, after the kickoff, where we talked all about the organizational stuff, let's dive into programming. I think this is the part where most of you are more curious about than just the organizational stuff. As you can see here, we will just dive into our first program, and I want to start with a very, very famous quote. The Hello World program is one of the most important programs ever written, said by ChatGPT yesterday. Yeah, okay, my fault. But I think the Hello World program is not only the most important, but let's say the most often written program. Yeah. So when you start with any programming language, you will always start with a Hello World program. What's a Hello World program? A Hello World program shows you the basic structure of a programming language, and in this case, it's our C programming language, which always needs this structure. So we need to write int main, then this parenthesis. We need this curly parenthesis here, and then printf. This is a functionality of C, and then we write hello world, and when we execute that, the output of the program is hello world. It's that easy, yeah? So this is the basic and the first example in every programming language. We will discuss all these components in detail over the next few weeks. So we will discuss in detail what this printf is today. We will also discuss what this main here means, I think in 2 weeks. But for now on, when we write code, we are pretending we know that it's not that important from the stage now. We are pretending we are executing code in this main, and we write our code here inside. Okay, but before we talk about the coding stuff, we should also discuss a bit where do we program, where do we write code. I had one colleague when I was in the first semester who told me you can write code in Microsoft Word. That's easy, yeah, that's the basic joke. No, spoiler, does not work. You can maybe write code, but you cannot execute it there. So when you write code, you always want to execute the code you have written. And one possibility we are highly using is VS Code. It's an open source tool, so you can use it for free. No, it's not open source, but you can use it for free, yeah. And we also encourage you to use that, because also in the practicals we will use VS Code. And it's basically a program, as you can see here. It has a file section on the left. It has an editor section where you actually can write your code. In this case, the hello world is inside. And it has a terminal section. And this terminal section then means you can execute the program here, and you see the output of the program. That's very important. How can we execute such a program? We need 2 steps, basically. The first one is we need so-called a compiler. We will discuss that maybe next week or in 2 weeks, but for now on, let's just pretend we need this command here. So we need this clang -v all, then the file name we are executing, and we are compiling to a program, yeah, and then we can execute the program by using this / and the programming name. So here's an example. When we are in the terminal, we call this command, pretending that our file we have written, our program, is named helloworld.c. So in C, the programs are written in C, have also the ending .c. Pretty straightforward. And this creates a new file, an executable program, and we can execute that with this / and the name of it. And then you can see it's printing out what we have written here inside. So the terminal section here means these two commands. If you don't understand these commands, it's totally fine. We will come to that when we discuss compiler in more detail. But I think in the first lecture, it's not necessary to talk in detail about what a compiler is and how to execute and how this works under the hood. I think it's sufficient when we talk about that in a few weeks. So from now on, just use this command to compile the program, which means we are creating our program out of the code. And to execute the program, we use this /. There is another alternative to VS Code, an online alternative, which is called Online GDP. There are many, but this is one we are using quite often. And this is, as I said, an online version to write and execute code. It has pretty similar components. It has some control buttons on top. You can use this run button to compile and execute. So this run button does basically what these two commands do. So you can run, compile and execute by click on this run button. You have this editor section where you have your code written, and again you have an output section, what is the output of your program. So especially in the beginning, maybe using VS Code is a bit too much because you have to have Linux or Mac OS for that, or at least a virtual machine or whatever. Online GDP is kind of an online version. You just need a browser. It's a bit easier to start writing programs. However, you will need some kind of local IDE, so VS Code or whatever, to program your assignments, because it will be too much otherwise in online GDP. But for more details about how all this VS Code works, and how you can get to have this IDE, get to start with all the commands and so on, the next practicals on next Thursday are dedicated just for that. So they show you how to use VS Code, how to maybe also use your Linux machine. If you have Windows, you can use a virtual machine, or you can also use a Docker container. So you have many possibilities. Unfortunately, executing code just on Windows does not work. You need somehow a Linux environment or a Unix environment. But for Windows, there are many possibilities. So you can have the virtual machine, or you can have the Windows subsystem for Linux, so the VSL, which basically is a small Linux inside of your Windows. But more on that in the practicals next week. Okay, let's go one step back. Computer science in general. So we showed you now a hello world. We showed you kind of the environment where you can work. But what is computer science in general? So this is a very, very easy example. But what computer science in general is, you have some input, then you have your program, and you have some output. and you want to convert the input to a specific output. And this black box here in the middle is basically what you should do as a computer scientist, the program you are writing. So this is the program you are writing, takes input. Maybe it's a user who enters something, and it should create some output. For example, if you are the developer of Microsoft Word, you take the input, the keys the user is entering, and as output, you should print it on the display. Basically, not that hard, but MS Word is a program that takes this input from the user and displays it on in the program or on this page then. Okay.
Yeah. I also, from my side, we just saw the input and some black box and then the output. And whenever we talk about input or programming and then output, we also have to talk about data. So first of all, what is data? So let's have a look at the very easy example, something maybe all of us have already seen in some similar case maybe. So we have a screenshot here of an Excel sheet where we have a table with different data in it. So let's have a look at the columns. We see an inventory ID, category, description, and so on. And if we have a look into the different cells in those columns, we see different types of data. So let's have a look at the first one. There we can see the inventory ID, which is basically some letters followed by some digits. So basically we can say this is text. The second column is the category, which is just a letter, and we say this data in this column is always a character. The third one, the description, has words followed by some specific specifications for products and so on. This is also text again. The next one is a unit price, where we can see numbers. So this is basically a number which is in each cell in this column. Then we also have quantity in stock, which is again a number. We see inventory value, again any price or value in currency, in euros in this case, which is a number again. And the last column, we just see yeses and nos, which means this is some kind of logical value, which is basically, two different states are possible, true or false, so in this case, yes or no. So, but let's take this to a different terminology now. So how do we see those data types in computer science? The first one, where we have this letters followed by digits, we call this text a string. So a string is basically text. It can be words, it can be many numbers, digits, characters, and so on. The next one is basically the character again. Then we have again text, which means we are talking about a string again. Then here we see the number, which is in this case a floating point number. So not a Ganzzahl, but a Gleitkommazahl, which is a floating point number with decimal points. So this is in computer science basically a float. Then the next one is again a number, but we see here just integer values, meaning Ganzzahlen in German. So this is an int or integer. And the next one again is a floating point value, a float. And then the last one, where we just have two different states, which means yes, no, or true or false, or 0 or 1, however you interpret it, is a Boolean or a short bool. Okay, now we have seen some different types of data that can be used in programming, that can be used as input values, but also as output values. And in our programs, we can use them to compute stuff. For example, compute the sum of two values and then print the result as output, for example. But to do so, we need a further concept, which is called variables. And variables can store data. And a variable basically is a named storage location, and it can store data. So it holds a value, and it can also change this value over time. So whenever we, for example, want to compute the sum of two numbers, and the user should enter those numbers first, we have to store those values somewhere, and this is the concept of variables. So we would have to introduce two variables where we want to store those numbers. Then we could compute, for example, the sum of those numbers and print it afterwards. But those variables can also change their value over time. So we could set a value, but we could also change it afterwards by some specific calculation that is needed, for example. And those variables are stored in the memory of the PC or the device our programming is running. So every variable needs some space on our device. So each variable has a memory location where it is stored in on the device. Then it has a value that is stored in there, and for sure it has a data type, as we just have seen before. So there are different types of variables. So for example, we can have variables that store numbers like integers, or even strings or characters. So we have to define first what data type should the variable store, and we have to define it. And here we have a short overview of the most important data types used in computer science in general, where we can see the first one, which is a Boolean. It just can store true or false, so just two different values, as we also have seen in the example before with yes and no. So there's just one bit needed for this type of information. So this is either 0 or 1. So it's either true or false. The next data type is called char, which is for characters. So we can store in a char variable just one single character, like this small h here. This character variable needs 1 byte, means 8-bit of size in our memory. Then we come to the numbers. The first one is an int or integer for Ganzzahlen, and it takes 4 bytes memory to store such an integer variable. The next data type is long, which means long integers. We have the double amount of bytes available here. As you can see, we have 8 bytes available for long integers. So we use variables from with the type long if we want to store very, very large numbers. The next data types are for floating point numbers, as we've seen before, the float. So we can store Kommazahlen in it. In comparison to the integer, where we can just store Ganzzahlen. For float, we can even store Kommazahlen. And the next one is the double, which is quite similar to the float, but here we can store more data. So we can have a higher precision, which is meant a double precision here. So we have 8 bytes available for each double variable, meaning that we can store numbers that are larger and with more precision regarding the floating points. And the last data type we want to show you here is the string, which we've also seen before. This is used for text in general, so words or sentences. Whenever we have more than just one character, otherwise we could use the char data type. So, and how much data do we need for such a string value? This for sure depends how long the text is we want to store in such a variable. This is a short overview about the most important data types. And now we come to the variable stuff in C, so to say. So how can we use variables in the programming language C? First of all, we have to discuss the variable declaration. This means that we introduce the variable, so we say to the compiler, here is a new variable and it has a name and a data type. So for example, we always start with the data type followed by a name. And the name of the variable can be defined by ourselves. So for example, if we want to store the age of a person, for example, and the age is always an integer, a Ganzzahl in German, then we would introduce or declare an int value with the name age. We also need a semicolon after each statement. The next example is a float value with salary when we want to store floating point numbers. And the last example is the declaration of a character value. In this case, this is just a declaration without setting the value of the variable. So if we just introduce them without setting the value, we do not really know what's the value in it. So what we want to have is we want to have an initialization. So we want to initialize the variables, meaning that we assign a value to the variable. For example, here we add to this declaration with int age the value 22 with this equal sign. So this means that after this statement, this introduced integer variable has the value 22. And for the float salary, for example, we store this value in it. And for this group variable, which is from type character, we store this a character in it. And good practice is to always initialize variables when declaring them. So because otherwise, if we do not do this, we do not really know the value, because then we just have our variable in the memory, but whatever was stored before in this memory space is then already there, and we do not know what's the correct value behind this variable then.
So declaring a variable does not mean it's always 0. We just don't know.
Yes.
Yeah.
So if you want to have a variable that is 0, then we have to initialize it with 0.
Yeah.
Yeah, and here are some suggestions for good readability and also bad readability in this case. The first hint is to give meaningful and descriptive names for your variables. For example, X is in most cases not that appropriate, but if you say you have a variable that is called Frodo age, I think, we then know it's maybe a person or a name, Frodo, with the age 33 then. With X, we do not really know what the reason of the variable or is then. Yeah. The next thing is that you should stay consistent with your naming of variables, and there is also naming conventions, and you should also have a look at our style guide, which is linked here, and you find it on our course website, where you can find rules how to make your code readable and how to stay consistent with different things. In this case, we are still working with variables, and here's an example of being not consistent. For example, we have Frodo age and then Bilbo age, and you can see that we have here some kind of camel case naming with uppercase letters, and here in this case we have the underscore as space between the two words. So better and consistent would be this example with always using underscores between words. A further example for a variable that stores the height of David in centimeters could be David height centimeters and the value.
Yeah. It's way better than just naming it X or whatever. Yeah. So when you read it, the computer does not. Computer is useless for the computer. What's the name? Computer can also work with X and Y and whatever. But for you as a programmer, it's easier to identify what the variable really should hold when you have a meaningful name. Okay, we have our first quiz, and we will have a lot of quizzes in all of the lectures. So what we want you to do now is to scan this QR code or go to slido.com and enter this code. And you should be able now to see the question and also rank or vote for the thing you think is correct. So the question here is, how would you best declare a variable that holds the balance of your bank account? So we have to consider here two things: the data type and of course the variable name. Yeah. So we have seen a lot of data types before. There are many data types, so we have to consider what is an appropriate data type for a bank account balance and what is also an appropriate name for it. Okay, let's wait another few seconds.
More than 200
great, yeah.
students already participated.
I've never tried it with so many students. I hope it will continue to run. We have over 300 views now. So let's see if we can reach 300. That's maybe a bit too ambitious. Okay, last few seconds, then we... okay, you cannot see this. Yeah, but you should see, we can remove that, but you should also see the question on your phone. Yeah. Okay, then 280. Yeah, we reached 280. That's great. Let's see. Yeah, perfect. So most of you have it correct. The best way to declare it is double my balance. Because, as I said before, the data type is also important. We have to consider the balance of your bank account most likely can have decimal places. Yeah, it should be good. Would be
Makes
good.
sense, yeah.
Makes sense, yeah. So an integer, for example, would not make sense because they cannot store decimal places. So I will lose the information. So that's why this one is not correct. Ooh. Let's go back. The long my balance is also a good idea, but a long is also just an integer, cannot store decimal places again. It's just a larger integer, cannot store, include decimal places. And the other one, X is not a good name. This would be a good name, but it's a bool data type, and I don't want my balance on the bank account to be just true or false. And int X is of course also not. So double my balance is a good variable name and a good data type. Okay, second quiz for you. Which statements are correct and work as expected? So these are initializations of variables. And based on what you have seen now, which one are correct and which one might not work as expected. So only mark the correct ones. Okay, let's wait another, let's say 10 seconds.
More than
Okay.
280 reached.
Great. Then let's see what you were saying. Okay, yeah. Integer attending students is 40. That works because in integer, so it's a Ganzzahl in German. Also the double current degree also works. We have decimal places and double can store the decimal place. No. Wait. Oh,
That's
it
correct.
works. Okay. Wrong. I was wrong.
The next one is interesting. So float my weight 55. Does that work too?
Yeah, that works. So float can store decimal places, but in this case it's just 55.0, which works, of course, yeah. Float bank account, 850.44 euro.
This is tricky, yeah.
It's tricky. So the first part would work, but you cannot write euros here at the end. So this will not work. So if we remove that, it would work again. Int salary 3104.09. Technically it would work, but it would just cut off these decimal places here. Yeah. So if you do it like this, the value then is just 3104.
Yeah. So the question was not just whether it works, but also if it works as expected, and it does not.
Does not as expected because we lose important information. And of course here, if you have an integer lecture hall, you cannot enter P1, which would be our lecture hall, but this is a character and a number, and currently we're only talking about numbers. You can only store numbers, and P is obviously not a number, so this also would not work. Okay.
Yeah, so far we have just seen how we can introduce variables, so how we can declare variables and how we can assign values to variables, but now we see how we can change those variables. So in this example we can see in the first line that we introduce, so we declare the variable age from the type int and we initialize it with 22. And then we have another statement here where we want to store the value or change the value to 55. And we can do it this way. So in this case, we do not need the data type anymore because this variable age is already introduced here with this declaration. So after this statement, the compiler knows, there is this variable age from type integer. And if we use age here again, then it's clear to the compiler that it's this integer variable. And if we assign this value 55 now, then this value 22 is overwritten and the age variable has this new value afterwards. So we have seen now data types and variables, how we can assign values to variables, how we can change values of variables. But now let's come to operators where we can do some stuff like computing, doing mathematical operations, calculations with variables and values, and therefore we need operators. The first one we've already seen before is the assignment operator. This is basically the equal sign as we've seen before. This is used to assign a value to the variable. And this works from right to left, meaning that we put this value into this variable here. So this is the assignment operator, and 11 is now stored in the integer variable x. The next operator is an arithmetic operator, namely the plus operator. So with this plus operator, we can do mathematical summations. So we can sum up the values of x and y. In this case, the value of x, so 11, is added by 4, the value of y, and then this result of this mathematical operation, so the result would be 15, is stored in the variable set afterwards. Yeah, we see the plus sign here, so for sure there can also be a minus, a multiply, which is the star, and also a slash for dividing. But the question is now, does this work? What do you think?
So we are so x is 11, y is 4. So basically we are dividing 11 by 4. Hard to calculate, but the result should be 2.75.
Okay, so the question is, does this work? Yeah, some say that the answer is 2, some say that this doesn't work, some say yes, but the result is rounded. So let's have a look at it. It works, so the compiler does this operation for us, but we have to be careful because the result of a division of 2 integers, so the left and the right operand of this operation, in this case x and y, are both integer variables, meaning that we divide integer by integer, and then the result is also always an integer in this case. And here the result is not mathematically rounded or something like that. So in this case, mathematically it would be 2.75, but it is an integer, meaning that the decimal places are cut off. So the result in this case for this operation is 2. So after this statement, the variable set has the value 2. So we have to be careful here.
One question, why does it round down instead of round up?
Yeah,
it's not really a rounding.
There's no rounding, right?
It's just cutting off because
Yeah.
an integer cannot store it.
Yeah.
So basically everything after this decimal point is just cut off.
So it doesn't matter whether it's 2.1 or 2.9. It's
Yep.
always cut off, and just this value 2 in this case remains.
But there have to be a solution for that.
Yeah,
right?
sure, because otherwise we couldn't make mathematical computations correctly in C. So let's try out this. So what happens now? I store the result in a float value. What happens now? Does this work? We have to be careful again, because the value of this variable set is again 2 and not 2.75, although it's a float and it could store a floating point number. But why is that? The problem is that the decimal places are already cut off here, so they are truncated during the division process. So the compiler during runtime, the following happens: x is divided by y. So in this operation, the decimal places are truncated, and afterwards the result, which is already truncated, so it's just 2, the result, is stored in a float value. And so this information with 0.75 is already lost here, no matter which data type this variable has. Okay, so the solution here would be, or could be, there could be more solutions, but one could be that one of the operands, in this case the variable y, is a floating point data type. So in this case a float. Then we have integer divided by float, and then the result is also a float. So we could then do this operation mathematically correct and store the result, for example, in this float variable. So now the result would be 2.75. So what we have, the important thing here is that at least one operand needs to be a float or a double to have afterwards again a float or a double as the result. So integer divided by integer is always an integer and could then be a problem.
Yeah. So always be careful when you use division in programs, and if the result is not correct, that's the main source of issue most of the time.
So far we have seen operators that use two operands. For example, this plus operator, which uses two operands, in this case 6 and 6. And now we come to unary operators, those who that just need one operand. So for example, we have an x variable from the type int here, which has the value 0. And then we see here the first unary operator, which is a post increment. So this plus plus is an increment operator. And what this does is basically just adding 1 to the value that is stored in x. So in this case, x is raised by 1. So it's set to 1 afterwards. And then we have the same for minus minus. So it's a decrement which reduces the value by 1. So after this operation, it's changed from 1 to 0 again. So increment and decrement, always raising or decreasing by 1. But we have two different types of increments and decrements. As we can see here, we can do the operator on the right side, so having a so-called postfix increment. And we could also do it on the left side, so before the variable, and this is a prefix decrement in this case. And the difference here is that the prefix decrement or increment is executed before operations. So if I do not do just this statement, but if I have further operands in this line, for example, adding then 6 to this value, it would make a difference. So with the prefix decrement or increment, the value would first be decreased or increased, and then the next operation would be calculated or executed. And with the postfix increment or decrement, this one is executed afterwards, after all the steps that are, that could be in these statements here together. But I think you will have to do with this stuff then in the weekly exercises or later during the course. The next thing we want to have a look at is that we can combine those arithmetic operators we've just seen with the assignment operator. So, for example, if we have an integer variable x here, we could do the following. We can say x plus equals 6. And this is equal to this statement that 6 is added to the value of x, and the result of this operation is then stored in the value of x. So basically x is raised by 6. So we could combine these two operands in this way. So the result would be 11 here. Or another example, if we have a float value, in this case it's 10 stored in the float variable y, we could do y slash equals 5, meaning that we divide y by 5 and store the value in the variable y, which is then 2 after this operation.
I have a question here, because the most common problem or misconception of many students is often that. Let's switch to this code window here. If I have a variable x and I declare it with this, why does it not work to say x plus 5? So, on my opinion, as a beginner, I would say x is now 10. But why not?
The problem here is that this operation is executed, so x is added by 5, but the result of this operation is lost. So it's not stored somewhere. So we use the value of x to compute this operation, but we do not modify the value of x. If we want to store this result in x, we would have to do x equals to x plus 5. So then this result here would be stored in x, or we could do the short way, as we've seen, the combination of both operators. But if we do not store it, we just use it but not modify it.
That's one of the misconception every beginner has.
Yeah.
So I just wanted to mention that. Yeah.
Thank you. Yeah, and the last operator so far we have a look at is the address of operator. This is one that is used to, as the name suggests, to get the address of a variable. What does that mean? For example, here we have a character variable with the name A that stores some character, in this case the large letter A. And here we have printf statements that are used for printing something on the screen, which we have seen in the Hello World example before. And then there are also some characters here we will have a look at a little bit later in today's lecture. But the important thing here is that with this here we just use we get the value that is stored in the character A, which is in this case the letter A. But with this address of operator, which is this and sign here before the variable name, is the address, so the memory address where our variable is stored.
So we say that a variable always has a data type, a value, and a memory location.
Yes.
This is where we can get the memory location.
Yeah.
It's a number we don't know really, and we don't have to consider much about that.
Yes.
But for some cases we need that. That's why we show it here.
So for now it's maybe not that clear why we would need that, but later on during this course we will need these operators a lot. This operator a lot because this could be very useful in some cases.
Yeah. So basically we want to know where it is stored, not only what is the value, but also where it is stored. And I think we also need it for today if we use user input and in the end. Yeah. Okay. Yeah. I also saw some comments.
Yeah. It's also possible to write comments in our source code, but the comments are just for us programmers, but not for the final program. So the compiler, when it translates our source code to a binary file, to an executable, it just removes all the comments. So here we can see two different ways how to write comments. The first one is with a double slash, as we can see here. This means that all text after those double slashes in one line is a comment. So, and as I said, this is just for us programmers to make our code more readable, to explain what we want to do with this division, for example, in this case. But for the compiler, it doesn't make any, the compiler ignores it completely. So it removes it. And the second way to write comments is with a /* and ending with // and everything in between those two things is a comment. So for example, here we start our comment, which can then go over multiple lines, and here we end with our comments. So if we have some statements within our comments, for example, an int age or something here, this would be completely ignored because it would then be a comment. Okay? Yeah, and how to write comments and so on, we will learn that during the course, and it's also explained in our guidelines.
Yeah. Okay. We mainly talked about digits and integers, so numbers. But of course, when we program, we also want to use text in some cases. Yeah. So we call a single character is a character. Yeah. So a string or a text is just many characters after each other. So let's talk about characters. What is a character and what could be included in characters? So which characters do we actually need? We need this lowercase characters, so A to Z. release uppercase characters, so A to Z again, but uppercase. We also maybe need numbers. What else do we need? Maybe if we want to write a text, we should also want to have like a comma, a percentage, or whatever, so a point. So we want also some other printable characters. Maybe we also want some non-printable characters, like a tab or a space or whatever. Yeah, or if we want to have a new line in our text, yeah, so we start with a new line, that's also a non-printable character. So we somehow want to represent these characters, but we live as a computer in a very numeric system. Yeah, everything is just a number, and a computer does not really know what an A, what a B, what a C is. Yeah. So how does this work? There is one standard. It's called American Standard Code for Information Inter-Exchange, or in short ASCII. And they define the printables and non-printable characters. Yeah. So this is just a defined set of 265 characters. Why 265? Yeah, that has something to do with bits and bytes. So we have 8 bits is 1 byte, and 1 byte can show 265 different versions or different numbers. So what you can see here is this ASCII code, and each letter here, A, B, C, D, E, F, G, and so on, or here the lowercase letters, here are some special characters. They are related to a number. Yeah, so they're bound to the number. A is bound to this number here, and so on and so forth. So when you have this A here, it's just bound to a number, and in the systems or in the computer, it sees it as this number, but we as a human can then interpret it also as an A. Yeah, the same for all of the other letters. That's a pretty cool concept, because the computer think, for example, the F is 70, yeah, but we can also say, okay, 70 is a number, but we want to interpret it as a character, and in this case it's an F. And then you have a text, and the text is for the computer just many numbers, but when we interpret these numbers, we see a text then out of that. That's a pretty cool concept. This is basically how characters and then also strings work under the hood. Okay, we will talk about characters, I think in every lecture and in every practicals. We will use them quite often. There is then a dedicated lecture about strings, so the combination of many characters, and then we will dive deeper into that. But now I want to highlight the variables and the size of variables once again. Because we already know this slide here. We have this bool, we have the character, integer, long, and so on. So different data types we are using now. And we also saw these sizes here. We saw that, for example, a character has a size of 1 byte. An integer has 4 bytes, so it can store more values. Yeah, a long has 8 bytes, so it can even store even more values inside. Floating point has 4, double has 4 bytes, and a string, as I said, is just a combination of characters, which means it depends on the number of characters inside the string. Let's focus on the character as a data type now, because it has 1 byte. Remember, as I said before, a character can be interpreted as a real character, so the age, or it could also be interpreted as just a number, because under the hood is just a number. So when we look at the size of one character, we know it's 1 byte. 1 byte means we have 8-bit, and 8-bit means we can have 265 different values. 56, sorry, 256 different values. Which means that we're starting with the value 0, 1, 2, 3, 4, 5, and so on, and then 255. What does that mean if we need bigger values? So let's say we want to store the value 256 or 270 or I don't know, 1000 inside the character. What happens then? That's the question for you now. What is the value? So not the character values, not the letter ABC, but what is the value of this variable when I say char var, so a variable name var is 256. Remember, a character is 1 byte. 1 byte means we can only store the values from 0 to 255. Okay, few more seconds for you to decide. Let's see what you have voted for. Yeah, it's 0. Looks a bit odd, but it's 0. Why is this the case? You can imagine these bytes as a clock, for example, yeah? So you have this values 0, 1, 2, 3, 4, and so on. Half of it is 128. And if you have the value 255 and you add one more, you're again at 0. Because you cannot break out of this. You cannot display higher values with 1 byte. This is called an overflow. So we go higher than our data type can include or can cope with. So we then go a bit too much and start at the smallest number again. There is also the opposite. There's also the underflow. Let's say we have the 0, a number, and we say, okay, -1. So my x is 0, and then I say x is equal to x minus 1. Then I can come to 255 if I have 1 byte character. This is then the underflow. You might now wonder, how can we now represent negative values? Because we have 0, and when I subtract 1 from 0, I end up with 255. How could this be? Why it's not -1? There is one additional thing you have to enter when you are want to have positive or negative values, and it's called signed or unsigned. Unsigned in this case means that there is no sign before the numbers. This is what I've told you before. When I have 0 and I subtract 1, I end up with 255. This means I don't have this sign before the number, so I don't have this 0, or I don't have this -1, for example. It's just not possible. Unsigned means always positive values. Okay, what's the value of this variable when I say unsigned char -1?
The assignment operator is missing, right?
Yeah, the assignment operator is missing, sorry, yeah. Unsigned char, what was my ID here? Unsigned char -1, yeah. I think you just get it. When I declare a variable with an unsigned char and I say this variable is -1. Sorry for the typo. Okay, so when I have an unsigned character, so I have no sign, I cannot represent negative values, then, as you said correctly, I end up again with 255 because that's the highest number in my character set. When I have signed characters, so I have the possibility to have a sign before the number, so I can represent negative values, then it's easier because then I can say 0 -1 and then I end up with -1 because I have now signed characters. I can use this keyword signed, but by default, if I create an integer or a character or whatever, it's always signed. So if you do not write signed or unsigned, it's always signed. It always thinks you need the negative values. But this has one downside here, because as you can see now, when we go back to this one, when we have unsigned, by unsigned we can represent 256 different characters or different numbers, starting from 0 to 255. Here it's only half, because we have half of them are positive values, from 0 to 227, and half of them are negative values, from -1 to -128. So it shortens my space available for all my numbers. And this is what I have to consider, because when I have this value range of a character, when it's unsigned, it's from 0 to 255. Signed, it's from -128 to +127. You could also do that for integers, for example, but the numbers are getting huge now. Integers, if it's unsigned, you can have a range from 0 to 4 billion. Yeah, 4 billion and many million. If it's in the signed range, you can see it's again half. Yeah, so from -2 billion to +2 billion. For long, it's getting, I don't know what's the word for that. Yeah, it's getting huge for unsigned, and it's also getting huge for signed. And for floating points, you have approximately, so that's why the size matters here, you have approximately 7 decimal places precision. With the double data type, you have approximately 15 decimal places precision. That's just because you have a bigger size, so more bytes available, and you can store more information inside. So just as a short summary, when we say if we have an unsigned character, call this variable var, and we write -1 inside, the actual value is 255 because the unsigned character cannot store negative values. You have an underflow. If we have signed variables, like a signed character var -1, that's actually -1 because it has a sign minus before. If I only use a character var, it's also -1 because it's signed by default, so it uses this space here. And if I have a character var 128, this is minus 128 because the biggest number is 127 and the next number then is minus 128, and that last one here might be very confusing in the beginning because you enter a number and you get a completely different minus number out. So if you have a problem like that, it's most likely that you have an underflow or an overflow in your program.
So basically we as programmers should have to be careful when choosing the data types for our variables, right? So we have to think about what data we want to store to avoid such overflows, right?
And we always have to consider what values could this variable have, yeah? If I want to store the age, for example, I maybe can use a character because it's very, very unlikely to have an age higher than 255, yeah, or even 127, yeah. But if I have my bank account, it's, yeah, maybe I should consider another data type.
Yeah.
So depending on what the variable is storing and what the values could be for this variable in the future, you have to, should consider an appropriate data type. Okay, there is one keyword in C that returns us the size of data types. So when we have here again our character A or an integer or a long or a float, and then we print this using the size of my group variable, the size of my number variable, my big number, and my height variable, it then returns the size of the character is 1 byte, int is 4 byte, long is 8 byte, and float is 4 byte. So this really returns us how big is this data type in this system. And it's very useful for advanced concept, which we will have in a few weeks then. Okay. Are there any, have you spotted any questions about?
Yes, there's one question about the previous example. Maybe we could go back one slide. So about the last one, there's the question whether the last one is not a signed character. Yes, it is a signed character.
Yeah, signed is default. So if you do not write signed here or unsigned, it's always signed. If you want an unsigned, you have to declare it as unsigned character.
Yeah.
Or unsigned integer. So this unsigned works for integer and characters and long and so on.
Yeah, and the range for the signed character is shown here.
Yeah.
And yeah, here we can see that we have here this overflow.
Overflow in this case from biggest number to the lowest number which can be represented. Yeah, that's why if we create this one, we end up with 128, minus 128.
Yeah.
Yeah. When should I use signed and when unsigned? It depends. So when you know that your variable will never have negative values, as I said before, the age. So it's very, very unlikely to have a negative age. Yeah, maybe if it's before it's born, but most likely you don't want to consider that case, then it makes sense to use unsigned because the age can never be negative and you lose half of your space then if you use it signed. Then it would make sense, for example, to use unsigned. Yeah, but in, let's say, in many cases, using a signed character or integer is okay. Okay, then I think we have 5 minutes left, so let's go to the last two topics. Shouldn't be that much, but output. We already saw some output.
Yes, but so far we have seen many things with variables and operators and so on, but now we want to also present the user the result, for example, of a mathematical operation. This is done with an output, and for outputs we use printf. We have already seen it at the Hello World example. And how does this syntax with printf work? Basically, it's a format string. We come to that, what it is in detail, and it could be followed by arguments. So for example, if we want to print out just a text, a string that is fixed, in this case hello world, without any parameters, without any values from variables and so on, we just can pass this string with this quotes here to the printf function. What functions are, we will see in later lectures then, but for now it's important that we pass this string to this printf function, and the printf function does the printing for us. And then it would print out hello world on the display. And if we want to print the values of variables, because we, for example, did some calculations and so on, in this case we have an integer variables with the value 1, and we want to print out this value, maybe in combination with some text. We could do it like this. We write the text, so the format string, followed by the variables we want to print out, and the values of those variables, in this case it's just one variable, is inserted into a placeholder, and we have to specify the placeholder in our text, in our format string, where we want to put the value of this variable into. In this case we want to print out we are in ISP week, and then the value followed by another character and new line, and this is a placeholder for integers. %d is a placeholder for integers, and so we can print out our value. So in this case the output is we are in ISP week 1.
Yeah. So what does this %d, so why d?
D, so we come to the definition for placeholders. D in this case for a decimal number is for integers, in this case more precise for signed integers, but we have also other placeholders or so-called format specifiers. So if we want to print out characters, we use the %c placeholder, where we can put character values into. So if we want to print out the value of a character variable, for example a letter A that is stored in this variable, we use the %c placeholder. And we could use an arbitrary number of placeholders within one format string, but it has to fit the amount of variables we then add after the format string. Then we have something like %ld for long integers, we have %f for floats, we have %lf for long float, or in this case double, we have %s for strings, we have %p for pointer. In this case we want to present the address of a variable, which we've seen before with the address of operator, and %x is also a placeholder to show a hexadecimal number. So yeah, with printf we have also further options to define the decimal precision, and we could also define the output alignment. What does that mean? The precision of the output could be defined with this precision control specifier. Here we have a %f, but in between this %f we have a .2. This means that for this float that is added here for the output, that is inserted here, the output is shown with only 2 decimal points. So 0.2 means from the float in the output, 2 decimal points are shown after the comma.
And rounded in this case.
In this case, we can see it's rounded as well. Yeah, and then we can also define the output alignment. What does that mean? So in this case, we can see one time a -15 between the % and the s for string, and one time a %s with 16 in between. With the 16, this means that the output is shifted to the right, and 16 letters or 16 spaces are reserved for this output. And if I use minus and a number, in this case 15 spaces are used from the left to right. And then the output would be the following. So in this case we have a string and another string. So we have two placeholders in one format string. So we have to enter here two values, in this case this string and another string. Then we have again two placeholders, in this case a string and a float. So we have to pass one string and one float, and those values behind this comma could also come from variables for sure, as we have seen before. And this 16.2 means that this 0.2 is the same as above, so 2 decimal points rounded, and the 16 again is the space that is used for the whole output of this number shifted to the right. And then if we make this to those three printf statements, we get exactly this output.
Yeah, great. I know that's a lot now.
Yeah.
That's very detailed, and you don't have to understand it in detail now. But what I want to show you is, because I just saw it in the chat, if you have this printf hello and you have this new line inside, what this new line basically does is, where is my hello? Here, okay. So it creates a new line inside. When I use it like this and execute it, you can see it's just hello world with a space inside, and this new line is a special character, which just means it's
a line break.
It's a line break and goes to the next line. Yeah, that was a very short overview of the output.
Yeah.
As I said before, printing is, so this is advanced.
Very advanced for sure.
But if you, the basic thing we want to teach you is you can use this format specifier, and after the first comma you can add all your variables you want to show here. Yeah, that's the core message. And also in the weekly exercises you will have exercise about that. Okay, one last topic. I know we are a bit over time, I'm sorry for that, but it's just 3 or 4 slides. As I said in the beginning, we not only want to print something out, we just want to have input from the user, because user want to interact with our program. And there is the opposite of printf function is a scanf function, which waits for the user input. And what you write is you create an integer number, and then you say scanf %d, which again means it's an integer. You need this address of operator for this number to that scanf knows it should write the value you have entered into this variable, and then you can use printf to print out the value. So this is, as I said, the address of operator to get the address where I want to store the input. And now, okay, we remove that.
Time to finish.
Time to finish, yeah. So scanf is just one way to get user input. You will also have a weekly exercise where you should use scanf. It's not that complicated, just use it like here, and you give the program an input, and then you can process that. The alternative way is another function which is called getchar, which then gives you, if you write it like this, and writes the character you entered into this input variable, and of course then you can print it once again. So very short user input, user output, but best practice is here just work with printf, work with scanf, and you will get used to it. Okay, then we are at our conclusion page. So just to conclude for today's first lecture, the most important thing is that we have now variables, We can store information inside the variables. We have different types of variables, integer, characters, floats, double, whatever. We also have operators, so we can calculate with these variables, sum two variables, divide, multiply, subtract, and so on. We can use printf and scanf to interact with the program. So I can say, okay, I enter two numbers, and the program should calculate the output, or should calculate the sum of it, and then print it as an output. That's basically one of the weekly exercises. And what we also saw is that variables can be signed or unsigned. So you have this underflow, overflow, and you also have to consider the size of variables. Okay, that was it from our side. Thanks for being here. Thanks for listening to us. I hope it was interesting and insightful. If you have questions, and I know there will be many questions, maybe there are more questions than before today's lecture, but that's completely normal. You will get used to all this programming stuff in the next weeks. As I said in the kickoff today, please make sure to practice a lot and to stay up to date, and then you will get into all these programming tasks and programming terms. Check out our course websites, or if you have questions, feel free to ask them on Discord. Thank you also, Lucas, for being here.
Thank you too. Thank you all, and see you
then next week. Yeah.
Thank you.
Bye.
Bye-bye.